All right, so we're going to return to talking about naming today. But specifically, we're going to talk about naming compounds with what's called a polyatomic ion. I'm not sure what order I'm going to do the video presentations for this one, so you may have already seen a little bit of information about polyatomics. Back when we were doing Lewis structures, we actually saw a couple of examples of these. And all the polyatomics are, by the way, here's a list of a whole bunch of them that you're always allowed to use on an exam, right? You don't have to memorize any of these. Let's just pick out nitrate, for example. Right? Nitrate, by the way, notice the ATE ending, is this big giant clump of nonmetals that all have a 1- charge overall, right? That's what a nitrate ion is. This is an example of a polyatomic ion, many atoms with a charge, polyatomic ion, right? And so these are actually going to be involved in specifically ionic compounds, right? And so if you look back at what we talked about in terms of naming ionic compounds, we know, like for instance, never to use prefixes, right? We saw where we had to balance plus and minus charge, and then we had to draw a formula, or we actually had to come up with the name from a formula. And so that's what we're going to talk a little bit about today. So let's pretend that we have some sort of compound. Let's say we've got barium nitrate is a name that we need to turn into some sort of formula, right? So that's the goal here. And I'll erase this just for the time being here so that we can approach these problems the same way that we approached the last set of problems. You look at barium nitrate, right? First thing that should scream at you is that it doesn't end in IDE. And that's huge, right? Not ending in IDE is telling you that you need to look at the polyatomic list. So you look at this thing, you see an ATE ending, right? That literally is a red flag. Well, not literally, I guess. I don't have one of those. But it should raise a flag in your mind and say, whoop, we got to look at the list here of polyatomics. It is not a nitride, which would be just nitrogen from the periodic table, right? It is actually telling you there's a polyatomic there. So we're still going to do our big giant work area here, divided up into a plus and a minus side of the world here. We're still going to look up the name of, the symbol for barium. Now, however, we have to remember to look at that sheet because that tells us the charge and how many elements are actually in that particular thing. And when you look it up, you'll see, like we just had written on the board, that I've got an NO3 and also that minus charge, or a 1- charge. We go back, we say, well, what's the charge on barium? Well, barium is a 2+. And of course, we do our Crossy trick. But when we do our Crossy trick, you'll notice that that 2 comes down in front of here, the 1 comes down in front of here. So you're probably not going to be surprised to see BA, but what do we do with this NO3? Well, it turns out if we need 2 of them, it's very confusing to just put a 2 right next to the subscripted 3, and it looks like a 32. So what you'll often see are parentheses around polyatomics and the number, right? And so this is the proper formula for this barium nitrate thing. Notice that the true picture of this thing, if we're keeping track of all the parts, in fact, what these parentheses mean is that I have 2 of those NO3 1-. And you'll notice if you add up all the charges, we end up with electrical neutrality. So let's look at, now that we've done a name to a formula, let's do a formula and turn it into the name. Another example, ask yourself, is there a metal present? Sure is, right? We've got a copper. So we know that ionics require the work area. We've got copper taken 3 times. And now we've got this big giant group of elements. They're all nonmetals. That's classic polyatomic ion territory. So what you have to do is put on your PO3, and you have to look up the charge and the name of it on the little resource guide that I give to you guys. Turns out that this guy is called a phosphite. Phosphite with an ITE. And the charge is a 3 minus. And you probably know where I'm going with this. We need to make sure that the charges are balanced. If there's one of those, that whole side adds up to 3 minus. This whole side has to add up to 3 plus, which means that if this is truly going to spread out that 3 plus evenly, each one of those coppers has to be a 1 plus. And so, that being a copper, you look at the chart that I gave you, you'll notice that there's multiple charges possible for copper. This one is the 1 plus charge, so you need a Roman numeral. And the name of that is copper 1 phosphite, right? Lots going on there, lots to practice, but luckily there's all kinds of questions that you're going to be asked on the lab. And as I said, be really careful about Googling these things. I'm looking for you to Google so that I can say you're bad. Naughty, naughty. No discussion of naming chemical compounds would be complete without talking about the pain in the butt presented by this particular polyatomic, which is named ammonium. Ammonium has a plus charge. And you'd say, who gives a crap? Well, when you look at that big giant list that I gave you of polyatomics, you'll notice that they are mostly negatively charged with the exception of this one. Turns out that causes a little bit of a problem in terms of determining whether something's ionic or covalent. If you remember, I said the first thing you should ask is there a metal present? It turns out that ammonium takes the place of a metal in ionic compound. So I should really amend that statement that I said, which is to ask the question, is there a metal present? Really what we should be asking, is there a metal or ammonium present? And if so, then yes, it really is an ionic compound. So I just wanted to show you that there's nothing special about this. It just kind of makes our taking a formula and turning into a name or name into a formula a little bit more difficult. So let's start off with, let's say that formula, and we have to turn that into a name. And let's say that we have this is a name that we have to turn into a formula. Same kind of thing is going to apply. We're still going to divide the world into a plus and a minus side because we know that ammonium is kind of like an honorary metal, right? Turns out it just kind of confuses the picture. I'm sorry, I didn't invent it. And what we can do is recognize that we've got two NH4s and we've got one sulfur, and then we do the game with the charges. If we know we have a polyatomic, we have to look up the charge. Well, good news is ammonium is always a 1 plus. Sulfur is a 2 minus. We've got the full picture written out now. Name of this thing will be ammonium sulfide. Pretty straightforward. Ammonium chloride, we're going to do the same thing. Is there a metal present? No. Is there an ammonium present? Yes. So we have to kind of add that now that we're really fancy. We look up what an ammonium is. Look up what a chloride is with its charge, which is a 1 minus. We already have this thing balanced. Therefore, we've got a formula of NH4Cl. Hopefully that helps you out a little bit.